Okay, we talked about literal equations. We had problems dealing with literal equations. Hopefully you find them to be exactly the same as all the other equations we had. Are there any there you like to see worked? Any you had trouble with? 43. 43 was a formula. This is number 43. Now, problem number 43 is a very, very simple problem, but there's something unique you haven't seen before. Now, all the distributions you had before was called left-hand distribution, meaning you did something like 2 times the quantity, 3x minus 4. You have no trouble with this. This was called left-hand. This is exactly the same as 3x minus 4 quantity times 2. This is right-hand distribution. So you see, this is exactly. If they would have put the d in front of the parenthesis, you would have breathed through it. Since they put it behind, you say, hey, this is a new course. Just the same thing. This is multiply d times n, you get n d. d times the negative 1 is negative d. Now we're solving this for n. You want to get n all by itself. So our first step was to clear parentheses. We have cleared them. There are no terms to combine. Step 4 says get all your variables on one side. N is our variable. We have all the n's on one side. Step 5 says get all the terms that don't have an n up that side. So Kathy, what are we going to have to get rid of?
The a.
A
Negative d.
and the negative d. So we're going to add a negative a, positive d to both sides. If I do that, I have L minus a plus d equal md. Last step says divide both sides by the coefficient of your variable. Well, the coefficient of n is what you're multiplying n by. What's a d? So you can divide both sides by d. And there is your answer. Okay? Makes sense.
How about 11?
11.
Joe,
Yes.
is your mic switch on?
My mic switch is on.
It's on.
Not coming through at all?
Go ahead, keep going. Keep going.
Okay. Number 11. Number 11, we have ax equal a minus x.
I must have
So-
copied the wrong problem.
What's that?
I must have copied the wrong problem, then I have a fraction, c minus 2y over b equals a.
Oh, yeah, I'm on the wrong page. Okay. C minus 2y over b equal a. First step is to clear fractions. We have fractions here. So our LCM is b. We multiply both sides by b, and we come out with c minus 2i is equal to ab. Okay? Now, remember what I said, it doesn't make any difference which side you bring the y's on. We have them all on one side, though, so we leave them alone. What we're going to do now is we're going to add a negative c to both sides. And we get ab minus c. We're now going to divide both sides by the coefficient of y, which is negative 2. If I do, I get y equal negative the fraction. ab minus c all over 2. Now there is nothing wrong with this answer, Lynn. This is a good answer. What the book did is they turned this around.
Is that multiplication by negative 1?
You know, they factored out a negative 1 is what they did.
And that's how they flipped
Right.
it.
Anytime you have two terms separated by a negative, you can reverse their order as long as you negate the fraction. So that's what they did. They got c minus ab all over 2 positive. But this is a good answer. What we have on the board is a good answer. Okay. Let's go on. Now, we've been playing with the action word equal. What we're going to do now is change that word. We're gonna change the action. Example. On the board I have an expression. We have X symbol 3. That symbol means greater than. X is greater than 3. This represents a solution set. Now, what are all the values of X that will make this true? Well, 4 will make it true, 5 will make it true, 750 will make it true, 3.5 is going to make it true, 3 1/4, 3.00000001 will make it true. It's impossible for us to list all the elements that's going to make this true. But some way we have to represent all the elements that will make it true. And we do that by graphing. We draw the number line. Now, somewhere on the number line to the right of 0 is the number we call 3. And what we want to do is we want to represent all the values greater than 3. Does 3 make this sentence true? No. 3 is not part of our solution set. But everything until we get to 3 is part of the solution set. So the way we have of representing this is we write a parenthesis at 3. Parenthesis. Facing the direction we want to go. X is greater. The arrow shows you which way you want to go. That says go to the right. So we darken in everything to the right of the parenthesis, including the arrow, showing it goes on and on forever and ever. And there is the graph of the solution set. Let's make a slight change in our solution set. Not much. How does this new solution set differ from the preceding one? It includes 3. It has one more number in it. That's all, just one more. That number is 3. So to make the graph of that, again we have 3. Now we want to show that it includes 3. The way we do that is we put a bracket on 3. Bracket. Remember, parenthesis shows that that number is not included. A bracket shows that that number is included. And then again, we darken in everything to the right. Every place we have it shaded is part of our solution set. Well, let's change it. Let's suppose I have X, new symbol 1. What does this new symbol represent? Less than. Sure, less than. So now we want to represent X is less than 1. So somewhere, again, we have our number line, and to the right of it we have 1. How are we going to represent this solution set? X is less than 1. Kathy?
Parenthesis in the other direction.
Yeah, parenthesis facing to the left. And then darkening everything to the left. X is less than or equal to 1. Again, we have the number line, we have 1. Now, Lynn, what are we going to do?
You're going to put a bracket at the 1, and then the arrow shade.
Bracket at 1, facing to the left, darkening everything to the left. And there is the solution set. X is less than or equal to 1. On the board, we have what's called a compound sentence. We have -2 is less than x, and x is less than 5. What is this saying to you? What is this telling you about the solution set? What is the solution set? Help. Someone. Not many someones here. Hey, what'd that tell you about x?
X has a value between
That's the magic word. Between. X is between -2 and 5. So, oh my God.
Oh, jeez.
Yeah, this is your pet. I brought your pet down.
Oh, my.
Sorry for...
That's all right.
No. I looked before and I saw a splash.
Maybe the college would pay for
Yeah,
it.
reimbursement, Frank.
Wardrobe.
You have a slush fund back here?
It's a
Okay.
blot on your otherwise clean record.
You can get it out. Soak it in less toil.
That's 12.
Less toil.
I'll pass those directions on.
Happy last way.
Here we go now. We want to represent this. So somewhere we have a 0. To the left of 0 we have -2. To the right of 0 we have 5. So what we're going to do is we're going to put a parenthesis of -2, a parenthesis of 5. We're going to darken in everything between. Everybody got that? Okay. Let's suppose we have this. -2 is less than x is less than or equal to 5. So again, we have -2, we have 5. What are we going to do there? Lynn?
Include -2 by using a bracket. And to -5 bracket again and shade in between.
Very good. We're going to put a bracket at -2 facing to the right, a bracket on 5 facing to the left. We're going to darken in everything. Okay? Help. Beeb, what are we going to do?
We put a bracket at the 2
Bracket -2,
and put a parenthesis.
parentheses at 5, darkening everything. Last one. Okay, Beeb, what are we going to do?
Put a parenthesis at 2
Parentheses -2,
and a bracket at 5.
bracket at 5,
And darken
darkening
space.
everything. Sure. And there is the solution set. On the board represents all the solution sets we're going to need. Now, one thing you have to remember, that when you work with inequalities, we're going to be finding solution sets. Our solution set will come out to be one of these 8. Anytime you have an inequality, find the solution set. A part of the solution is the graph. It's automatic. Anytime you have an inequality, there is a graph with the inequality, always. Not only for this course, for any course in math above this level. Anytime you deal with inequalities, if you go on in math, you'll be doing a lot with inequalities. The graph is part of the solution. Now, we know how to graph the solution. What we have to do now is be able to find the solution. So we need some properties. Now we're going to talk about properties of inequalities. you're given that A, B, and C are real numbers. Now again, remember what we mean by real numbers. Any number that doesn't have an I with it is a real number. Okay? Now, I'm going to be dealing with the word less than. But the same properties hold true with the word greater than. Same properties. Now, one. If A is less than B, and B is less than C, then what can we say? What has to be true? If A is less than B, and B is less than C,
Then C less than
A is,
less than C.
yeah, A is less than C. Sure, that makes sense. If I have less money than Wong, which is possible after I buy new insurance, and Wong has less money than B, then it makes sense I have less money than B, right? That's all we're saying there. 2. If A is less than B, then what can we say about A plus C and B plus C? If A is less than B, how does A plus C compare to B plus C? Lynn?
Plus C should be smaller than B.
A plus C should be
Smaller.
smaller. I don't
No.
know. Yeah, well, it should be, we say less than.
Yeah.
Because here, look at this, okay? Which is the smaller number?
Or if you're assuming zeros on the right.
No, just a smaller number. Smaller deals with.
Yeah, less than.
Yeah, right, less than. Okay? Okay. So she says A plus C has to be less than, well, let's see if that's true. Let's start off with 3 is less than 5. Now what this says is to add some real number, the same real number, to both sides. So I'm going to add a positive number to both sides. I'm going to add 4 to both sides. So I get 3 plus 4, 5 plus 4. Well, 3 plus 4 is 7, 5 plus 4 is 9. How does 7 compare to 9? It's less than. Well, it works with a positive number. Let's see if it works with a negative number. Again, let's start with 3 is less than 5. This time let's add some negative number to both sides. Let's add a negative 6. See if Lynn is telling us the truth. I'm adding a negative 6 to both sides. That's what it says, add something to both sides. Well, if I do that, I get negative 3. Here I get negative 1. How does negative 3 compare to negative 1? It's less than. So Lynn told us the truth. AC is definitely less than BC. This is that any time you add the same thing to both sides of an equality, it has no effect on that symbol. None. Symbol stays the same. If A is less than B, then AC, BC. How does AC compare to BC? Lynn?
The same thing should hold.
Same thing should hold, Lynn said. Well, let's find out. Again, I'm going to start with 3 is less than 5. Now this says multiply both sides by the same number. So I'm going to multiply, well I added 4, let's multiply both sides by 4. Here I get 3 times 4, that's 12. I get 5 times 4, which is 20. How does 12 compare to 20, Lynn?
It is less than.
Definitely. Now we try to pause it, let's try that. You know, we did it with addition, let's do it. Let's multiply both sides by -6, Lynn. If I multiply the left side, I have 3 times the -6 is,
-18.
if I multiply the right
It's
side,
-30.
how does -18 compare to -30? How does -18 compare to -30?
-30 is less than.
Yeah, but you told me that this
It
was...
doesn't work.
Oh, when does it work, Lynn? It did work one time.
What, not for the negative numbers.
Yeah, but what's it work for?
Multiplication. The positive, negative,
Okay,
or the
work.
positive numbers, it works.
If A is less than B, then AC is less than BC if C is...
A positive number.
If C is positive. Now, the way we write C is positive. Mathematical symbolism. C is greater than 0. If C is greater than 0, it means it lies to the right of 0. That means it's positive. Okay? 4. If A is less than B, then AC is greater than BC if... What?
If it's a negative number.
Yeah, C is
If C is smaller than 0.
Yeah. If you're multiplying both sides by a positive number, it has no effect on your symbol. If you multiply both sides by a negative number, you have to reverse the order of the inequality. That means flip-flop the symbol. Anytime you multiply both sides by a negative, you have to flip-flop the symbol. So now that we have the rules, we know how to graph a solution set, let's get after one. Let's suppose I have 3x plus 15 is less than 5x plus 21. Now what we have on the board is a mathematical sentence. This is 3 times some number increased by 15 is less than 5 times the number increased by 21. Now our job is to find the solution set for this equation, for this inequality. Now, what's the first thing we're going to do here? What's the first thing you want to do? Kathy, what's the first thing you want to do? Take a shot at something, Kath. You have another background. You should be able to think of something. Yeah! We're going to add a negative 5x to both sides. If I add a negative 5x to the left, I get negative 2x plus 15. I get 21. What about my symbol there? What does it do? Does it stay the same? Does it change? Help. Help. What about the symbolism? What happens? Somebody. Stays the same short. Why? Why? What did you do, Kath? What did you do in order to go from here to here?
Added.
You added. And property 2 says, hey, you can add anything you want to both sides. And it has no effect at all on the symbol. Okay, Kath, we have all the x on one side. What are we going to do next? Add a negative 15 to both sides. Well, if I do that, I get negative 2x is less than 6. Notice what I did. I added a negative 15. What are we going to do now, Kath?
Detracts.
What are we going to do next?
Divide
Divide?
by
Right.
negative 2.
Yeah, divide both sides by the coefficient of x, which is negative 2. If I do, I get x here. I get negative 3 here. Question is, what happens to our symbol?
It's wrong.
It changes. Sure it
Change
does.
the change.
Why? Well, You don't have it. What did you do? You told me you divided. And you divided both sides by a negative number, is what he did. But actually, as you go on, you lose division. Dividing by 2 is the same as multiplying by 1/2. And that's what he did. He multiplied both sides by a negative 1/2. He multiplied both sides by a negative number. That says reverse the order of the inequality. And there's our solution. We make the graph of it. Somewhere to the left of 0 is a number we call -3. We put a parenthesis on it, and we darken in everything to the right, including the arrow. Notice it's a parenthesis. It's a parenthesis if the word equal was in our solution set. It would be a bracket. No bracket, it's a parenthesis. Now, thing I like to emphasize is working with inequality. You work it exactly the same way you would equation. Exactly the same. Clear fractions, clear, all that. The only difference is if you multiply or divide by a negative, you have to reverse that order. You have to flip-flop that symbol. If you don't multiply or divide by a negative, it's exactly the same. All the way through. So, let's try a few problems. There you go. 3 times the quantity, 4x minus 7, is less than or equal to 5 times the quantity, x plus 6, plus 5. I think this comes out real nice. Remember, you solve this the way you would any equation. First step says clear fractions. We don't have any fractions. Second step, clear parentheses. We have parentheses. If I clear them, I have 12x minus 21 is less than or equal to 5x plus 30 plus 5. Step 3 says combine like terms. Well, we came over on the right. Step 4 says get all the x's on one side. So we're going to add a negative 5x to both sides. And we said we're allowed to add anything we want to both sides, and it's not going to have